Example 3 says inflating a balloon. It says air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. I see cubic, I'm thinking volume, okay? Find the rate of change of the radius when the radius is 2 feet. Okay, so let's look at this. They want the rate of change of the radius. Rate of change in the radius. So what do they want? They want the rate of change in radius would be r prime. Let's think about what's given to us here. It says air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. Cubic feet, that's the volume, right? So we know that the volume is changing by 4.5. So V prime, the rate of change of volume, has to be 4.5. Again, I don't care about the units until the final answer. Okay? And then what else do they give us? They give us that the radius is 2 feet. Again, we cannot plug in the given information until we've determined the equation and taken the derivative of both sides. So let's look at this and think about this. What is the equation? Well, this is a spherical balloon, so we're looking at the volume of a sphere. So you need to know that the volume of a sphere is given to you by 4/3 pi r cubed. That's the formula for the volume of a sphere. Okay, what do? Take the derivative with respect to t of both sides of the equation. So what's the derivative of v? That would be v prime. The derivative of 4/3 pi r cubed, again, 4/3 pi is just a constant, so this would be 4/3 pi times, well, the derivative of r cubed would be 3r squared, but then you have to use the chain rule, so I'd have to multiply that times r prime. Let's clean that up a little bit. I see that the 3's are going to simplify. So I'm going to have 4 pi r squared times r prime, right? Now and only now I can plug in the given information. So let's look at that given information. They gave me v prime was 4.5 and they gave me r was equal to 2. So let's plug in that given information. I have 4.5, sorry, 1 second, let me get my pen. I have 4.5 equals 4 pi times 2 squared times r prime. Well, let's just do the math. 2 squared is 4, 4 times 4 is 16. So this is 4.5 equals 16 pi times r prime. Let's divide both sides by 16 pi to solve for r prime. And when I do that, I'm going to get r prime approximately equals, so on this one, I'm going to estimate it to see what it is. So in my calculator, I'm going to do 4.5 divided by 16 pi. I hit enter. And I'm getting a value approximately equal to, I get 0.0895. So I'm just going to estimate it to 2 decimal places. Again, it didn't tell me what to do. So I'm going to do 0.09. How about that? That works. And it looks like they did the same. Now let's think about the units here. That's what r prime is. Okay. Sorry, I should have put that up here. 0.09 is what I approximately got. Let's think about the units. So this is the radius. The radius is a distance. It's changing in terms of feet. And then with respect to time would be in terms of seconds in this one. Or sorry, per minute in this one because it says cubic feet per minute. So my final answer would be 0.09 feet per minute is what the radius is changing by. Okay, let's continue on. Get a little more complicated here. I love this problem, one of my favorite test problems, or not necessarily one of mine, but one that I see on almost all tests when teachers write these types of tests. Nice example here of Pythagorean theorem, so let's give it a try. Again, there's an interactive example. You can download this from the textbook if you want, but I'm just going to go ahead and do the problem. It says an airplane is flying on a flight path that will take it directly over a radar tracking station, as shown in figure 3.38. The distance s is decreasing at a rate of 400 miles per hour when s equals 10 miles. What is the speed of the plane? So let's think about this. The plane is traveling in a horizontal direction going towards this area right here. So when we find the derivative, the distance is decreasing, so my rate of change should actually be negative here because the distance is decreasing. Now, if they want to know the speed of the plane, we have to do the absolute value of the answer. So let's say we got something like negative 300 miles per hour. I have no clue what the answer is. That doesn't mean that it's traveling at negative 300 miles per hour. That means it's getting closer and closer to the station at 300 miles per hour. So the speed would be 300 miles per hour. So let's go ahead and figure this out and see what's given and what they want. So what do they want? They want the rate of change of the plane, the speed of the plane. Well, that would be the rate of change of x. In other words, they want x prime. Let's also think about what's given. It says, if you look, s equals 10 miles is certainly given to you. And what else is given? What else is given is s is decreasing at 400 miles per hour. So s prime here would be negative 400. Again, we don't really care about the negative because we're just talking about speed, but because it says decreasing, I'm going to put a negative there, okay? I'm also going to redraw this triangle for you. So this side right here is fixed. So here we have x and here we have s, and this most definitely is a right triangle. So what formula could you see with this triangle? Or what equation? The equation that I could see with this triangle is the Pythagorean theorem. I know that the side squared plus the side squared equals the hypotenuse squared. So in this case, it would be x squared plus 6 squared equals s squared. That would be the equation of this triangle. In other words, it would be x squared plus 36 equals s squared. So what's my goal here? My goal, again, once I find my equation, is I want to take the derivative with respect to t of both sides of this equation. The derivative with respect to t of both sides. So what's the derivative of x squared? The derivative of x squared is 2x, remember that chain rule, times x prime. The derivative of 36 is 0. We don't worry about that. What's the derivative of s squared? The derivative of s squared is 2s s prime. Okay? Let's look at what's given to us. See if we can plug it in. We know that s is equal to 10, so we can plug that in. We know that s prime is equal to negative 400, so we could plug that in. Remember, we're trying to solve for x prime, but we got a bit of an issue. The issue is we still need to know what x is. So the question is, how do we find x? And that's something that you need to find up front. So I'm going to do that over here. I'm going to write need to find x. So let's think about how we're going to solve for x. Well, let's look at that triangle again. Here's that triangle. Here we have its 6. Here we have its x. And then on the right-hand side, we have s. And we care about the moment when s is equal to 10. So the question is, can we find the length of x at this exact point in time? And the answer is yes. Let's use Pythagorean theorem. We know x squared plus 6 squared equals 10 squared. That's x squared plus 36 equals 100. Subtract 36 from both sides, you would have x squared equals 64. Take the square root of both sides, and you would have x equals 8. So now that we've solved for x in that specific moment of time, this is not what x always is, this is just that specific moment of time, now we can go back to our equation and plug it in. So going back to our equation, I'd have 2 times x, which was 8, times x prime, equals 2 times s, which was 10, times s prime, which was negative 400. Let's do some math here. 2 times 8 would be 16x prime. 2 times 10 times 400, well, that would be, times negative 400, would be negative 8,000. Divide both sides by 16, and I'm getting x prime equals, let me do this in my calculator, 8,000 divided by 16, hit enter, and I'm getting negative 500. Remember, this is negative 500, meaning the speed of the plane is, or the distance is decreasing between it. It's approaching this whatever radar station or whatever they called it, okay? at a rate of 500, but 500, we need to know what it is. Well, distance is measured in miles and time is measured in hours, and it's distance over time. So the final answer would be the plane is traveling at 500 miles per hour.